Welcome to Saxon Math Course 3, Lesson 108, Starred Problems. The first starred problem in Lesson 108 is question 3. Question 3 gives us a graph and says if ABC is reflected across the line y equals 1, what will be the coordinates of point C prime? Now, the way we do this is this is the line here of y equals 1. We look at each point in the graph, point A, point B, and point C, and we say how far away is point A, B, or C from the line? Well, point B is one space. So we go up one space here, and this is point B. Point C is two spaces, so we'll go up two spaces, and that'll give us point C. Point A over here, this is 1, 2, 3, 4, 5 spaces. So we'll go up 1, 2, 3, 4, 5 spaces. And then we'd connect it, and this would give us A prime, B prime, and C prime. Now, it wants to know what are the coordinates of C prime. Well, this right here, it looks like it might be 0, 2, but remember that this is the line y equals 1. So that means down here my axis, so up 1, 2, 3, and it's 0, 3. The next starred problems are question 4 and 5. Question 4 and 5 ask you to give the x and y intercepts and then graph the problems. So I'm going to do them both on the same graph here, but this is not a system of equations. Now, for 3x plus 5y equals 15, 5y would equal 15 when x is 0, because 3 times 0 is 0. 5y equals 15, if we divide both sides by 5, we'd get y equals 3. If 3x was equal to 15 because the y was 0, dividing both sides by 3 would give you x equals 5. So my two intercepts are 0, 3, and 5, 0. Now, this one here is my y-intercept. This here is my x-intercept. The value you're finding is the axis you are intercepting. So, for the y-intercept, we're going to go to 0, 3. For the x-intercept, we go to 5, 0. 1, 2, 3, 4, 5. And then we connect those dots. Then for question 5, we have 2x plus 4y equals negative 12. If x is 0, we just have 4y equals negative 12. Dividing both sides by 4 would give us negative 3. If 2x was equal to negative 12, dividing both sides by 2 would give you negative 6. So here you would have negative 3 and negative 6. Now, that will give us 0, negative 3 right here, and negative 6, 0 over here. We take our straight edge, and we connect the 2 points to give us a nice line. All right. Where this was 0, negative 3, 6, negative 6, 0. This one over here was 0, 3. And this was 5, 0. The next starred problem is a probability question. It has to do with a bag filled with marbles. Now, the question gives us to start off with that you draw 2 marbles from a bag containing 21 red marbles, 5 blue marbles, and 10 green marbles. Part A says, what is the probability of drawing red and then blue without replacement? Well, how many red marbles are there? Well, there are 21 red marbles. How many marbles are there? Well, 21 plus 5 plus 10, that's the red marbles, the blue marbles, and the green marbles, is 36. So it's 21 out of 36 marbles are red. We then have to find the probability of picking blue after having picked red. Well, there are 5 blue marbles, and after we've taken one red one out, there would only be 35 marbles left. And then we look for things we can simplify. Now, 5 and 35 are both divisible by 5. We can cancel out a 5 between them. 5 divided by 5 is 1. 35 divided by 5 is 7. 7 and 21 are both divisible by 7. 21 divided by 7 is 3. 3 over 36 can be reduced to 1/12. Now, we are then asked to find the probability of drawing blue and then red without replacement. To start off with, we have 5 blue marbles, and total marbles is 36. Having picked out one blue marble, the red one will be 21 out of 35. We can cancel out a 5 out of 5 and 35, which will give us 21/7 times 1 over 36. We can cancel a 7 out of 21 and 7. 21 divided by 7 is 3. 7 divided by 7 is 1. 1 times 3 is 3. 36 times 3 is 1, which gives 3 over 36, which could be reduced to 1/12. Part C says that drawing blue then red in either order without replacement. So the probability of drawing blue then red or red then blue. Whenever we have an or statement in a probability, we're going to add. So the probability of blue then red was 1 over 12. The probability of red then blue, also 1 over 12. 1/12 plus 1/12 is 2/12, or 1/6. We're then finally asked to find the probability of not drawing exactly one blue or one red without replacement. Well, we're going to take 1 minus the probability of blue then red or red then blue. We're not going to write 1 as 1 though, because we know this probability is 1/6. The fraction from which we could subtract 1/6 that is equivalent to 1 is 6/6. 6/6 minus 1/6 is 5/6. And that is problem 6. Our next start problem is problem number 7. Problem number 7 gives us two equations that tell us the ages of Marla and Jill. We're told that Marla is Jill's older sister. The sum of their ages is 12, so Marla plus Jill is 12, and that the difference of their ages is 4, so Marla minus Jill is 4. Now, it says to graph the system of equations to find out how old Marla is. Well, in x plus y equals 12, if we replace either of these with 0, the other one will become 12. Because anything plus 0 is itself. For y minus x equals 4, if we have y minus 0 equals 4, y is 4. If we have 0 minus x equals 4, then x will be negative 4. So we have the points 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 0, 12, and 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12, 0. When we connect those lines using a straight edge, we get this line here. Should probably go through the points, because you never know where your intersection is going to be. In this problem, we know that it's going to be a positive number for both of them because we can't have negative ages. Now, for this one, we have 0, 4, and 4, 0. Now, when we connect these lines, we get a clear intersection right here. And this is at the point 4, comma, 1, 2, 3, 4, 5, 6, 7, 8. Now, since Marla is the older sister, and 8 is older than 4, Marla is 8 years old. Our next star problem is problem number 8. What a coincidence. Now, problem number 8 gives us 2 cones. Looking at these cones, we see that the radius of the larger cone is 3, and the height of the larger cone is 6. We can also see that the radius of the smaller cone is 2, and the height of the smaller cone is 4. Now, we're asked to find what is the scale factor from the small cone to the large cone. If we're going to the small cone to the large cone, we put the large over the small. So let's take the radius, for example. We can say 3 over 2. Now that's reduced, but we could also write it as 1.5. Then we need to find the ratio of the areas. Remember, looking back at our table, the ratio of the areas is equal to the scale factor squared. So it would be 3 over 2 squared. Now, 3 over 2 squared is going to square the 3 and the 2. 3 times 3 is 9, and 2 times 2 is 4. Part C asked for the ratio of the volumes. The ratio of the volumes is the scale factor cubed. Our scale factor was 3 over 2. So 3 times 3 times 3 is 27, because 9 times 3 is 27. And 2 times 2 times 2 is 8. That's part A, B, and C of question 8. Now our next question, question 9, has to do with these 2 cones as well. It's going to ask us to find the volume of the larger cone in terms of pi, and then find the volume of the smaller cone. Now the volume of the larger cone can be found with the formula 1/3 times the radius squared times the height times pi, as you'll see here. Now, we have 1/3 times the radius squared times height times pi. The radius in this case was 3, so 3 times 3 times, 3 squared times the height, which was 6. Now, 1/3 of 3 squared is 3. 3 times 6 is 18, so we'd have 18 pi cubic inches. If we're finding the volume of the smaller cone, we could use this same formula again, or we can use the ratio of the volumes. Now, we know that it's 18 pi inches, so we can use the volume of the larger cone times the ratio of the volumes to get the volume of the smaller cone. So 18 pi over 1 times the ratio of 8 over 27. Now, we can cancel out a 9 from both 18 and 27. 18 divided by 9 is 2. 27 divided by 9 is 3. 2 times pi times 8 is 16 pi over 3 cubic inches. And you can see that this can reduce some of the time spent going through the formula if you've already found one part of a similar shape. Question 12 says that Brenda averaged 8 points per game in her first 3 basketball games. How many points per game does she need to average in her next 2 games to have a 5-game average of 10 points per game? Well, the way we would do this is we would set up all of our information. We would say we've got 3 games going 8 points per game. Altogether, if she has 3 games where she's averaging 8 points per game, that means she's got 24 points across those 3 games. To get a 10-point per game average over 5 games, we would need a total of 5 times 10, or 50. Now that we know the two total points, the points we start with and the points we want to get to, we can use those two pieces of information to find the amount of points we need, because we can subtract 24 from 50 to get 26. And if we need to get 26 points total in 2 games, that's an average of 13 points in each game, because 26 divided by 2 is 13. Question 13 says, in 2 hours, Barton drives 120 miles from his home near Lubbock to visit a friend near Amarillo. Due to weather, the return trip takes 3 hours. Part A says find Barton's average speed from Lubbock to Amarillo. Now, speed is miles per hour. So we take the miles that he went, 120, divided by the time it took, 2 hours. 120 divided by 2 is 60 miles per hour. Now, our next part asks us to find the speed on the return trip. Now, the return trip is going to be the same distance, because if you go from where you start to where you end, and then back from where you end to where you start, each part of that is the same distance. So we'll do 120 divided by the new time, which is 3 due to weather. 120 divided by 3 is 40 miles per hour. We're then asked to find his average speed for the whole trip, or round trip. Now, to do that, we need to find the round trip distance. If he goes 120 one way and 120 the other way, we add 120 plus 120, and we take each time as well, 2 plus 3. 120 plus 120 is 240. 2 plus 3 is 5. So all we need to do is divide 240 by 5. Now, 240 is 5 times 48, because 5 times 8 is 40, and 5 times 40 is 200. And that will be our average speed for the round trip. You'll notice that this is closer to 40 than it is to 60, and that might feel a little bit confusing because they went the same distance. But remember, if he spent more time going 40 miles per hour than he did going 60 miles per hour, the average for the whole thing is going to be closer to what he spent more time doing. Our next starred problem is 22 and 23. Now, 22 and 23 have to do with a milk carton, which I've drawn over here. Now, the milk carton has a prism in its bottom half and a pyramid going up the top. Now, the pyramid and the prism both have a base of a 9 by 9 square, and the prism has a height of 20. The pyramid has a height of 2, but a slant height of 5. Now, the volume of the carton is equal to the volume of the pyramid plus the volume of the prism. We're asked in 22 to find the volume of the carton. So to start off, we're going to find the volume of the pyramid. The volume of the pyramid is 1/3 times the base area times the height. Now the base area is a square, so it's 9 times 9. 9 times 9 is 81. 1/3 of 81 is 27. So we're going to go with 27 times 2. Now, 27 times 2 equals 54. Now, that's 54 cubic units, and I believe we're working in, let me check the book, centimeters. So it's 54 cubic centimeters. The volume of the prism is going to be the area of the base, 9 times 9, times the height of the prism, which is 20. 9 times 9 is 81. 81 times 20 is going to be 2 times 81 is 162, so 1,620. If we add 54 and 1,620, we're going to get 1,674 cubic centimeters. And these are all in cubic centimeters. For 23, we're finding the surface area of the carton. Now, the surface area, we're going to need to find the base area of the bottom of the carton, the lateral area around the carton, and the lateral area around the top of the carton. So we need to find all three of these and then add them up. The easiest one is the base area because it's 9 times 9. The lateral area is the perimeter of the base, 9 plus 9 plus 9 plus 9. That's 4 nines, so 36, times the height of the shape, which is 20. And then for the lateral area of the pyramid, it's going to be 1/2 times the perimeter of the base, which is still 36, times the slant height, which here is 5. Now 9 times 9 is 81. 36 times 20 is 720, because 2 times 36 is 72. Half of 36 times 5 is 18 times 5. 18 times 5 is 90. Now, 81 plus 720 plus 90 is 891. Centimeters squared. Now, our last starred problem gives us a graph and asks us to represent the data in a table. So this is a graph of library visits. We have visitors and days of the week. Now, on Monday, we have 20 visitors. So we're going to put a 20 in Monday. On Tuesday, we can use a straight edge to make sure there are 30 visitors. On Wednesday, there are 50 visitors. On Thursday, we have I made this a little bit too tall in my version. The graph in the book actually ends at 70. Now, on Friday, we can check. The graph ends at 40. And on Saturday, it goes to 30. And that's all you have to do. Now, that is the last star problem for this lesson, as it is also the last problem in the lesson. So stay safe, stay inside, and wash your hands.